Today's problem is very simple. We are given two strings. One is a smaller string, or it can be larger, and another string is the bigger string. And we have to check whether S is a subsequence of T or not. So subsequence is means that you pick some characters from a sentence, from a string, maintaining their order. For example, I pick H, then I pick G, and then I pick, let's say, C. So you will see that H occurs first, then G, then C. And in this string from where we have picked it, there also they occur in the same order. That is, H occurs first, then G, then C. Then HGC will be a subsequence of this string. But on the other hand, if we write it like GHC, although the characters are same, we see that where is G? G is here. Then after this, we look for H and we do not find it, although it's before. So it's occurring in different order in this string, but here it's in different order. So this is not a subsequence of this, and this is a subsequence of this string. So here also you have to check whether the given string S is a subsequence of T or not. So for this example, if we see that is A present or not, first of all these characters should be present. If the character itself is not present, there is no notion of ordering. We straight away return false. So we check if A is present or not. We see that yes, A is present here. There can be multiple instances of A as well. So we see that one character I have found. Next we look for B. So we pick characters in order in S and we look in T. So wherever we found the first character, we look for the next character there onwards. So we found A in the beginning itself. So we look from second character for B, and we found a B here. So we move to the next character, which is D, and try to find it, and we found it here. And now there are no characters left here. So we say that yes, return true. But if this is not a substring, let's say we have some other character here, let's say A, B, X, then we see that A we found here, this is S, this is T. Then we look for next character B, we found here. Then we look here onwards for X. We go here, we don't find, we reach the end of T, and this we did not find, so we return false. Similarly, let's say we are given A, C, B. So we see if A is present, yes, it's here. Then we look for C. We continue. We found C here. And then we look for B, but we see that there is no character left, so we return false. So the algorithm is very simple. If first characters match, is sub, let's say this is the function and we are calling it on S and T. So if S0 is same as T0, that is first character match, then our job is reduced. Just look for this substring in this substring, whether this subsequence is present in this or not. So return is sub S1 onwards. So this will denote, this slice will denote first to last character, and comma T1 onwards. Else, that is first characters are different, so we will not advance in S since we have to find all the characters of this S. So we did not find A here. So what we are left with, we will find this entire S in this part from first to last character. So in this case we will return is sub S, complete S, and T1 till end. And so here we are using recursion. This is the main function, and we are recursively calling this function on a smaller substring of S and T. And finally, when should we return? if S is non-empty and T is empty. So if S is empty, that means we have searched for all the characters of S and we move to next character only when we found the previous character in the same order that we followed. So if we found B here, next character we look from here onwards. So we never do second scan of this array. So if at any point of time, if in this recursive call, if s.length is 0, that is all characters are found, or maybe that the input was itself 0, then we have nothing to find, then return true. And if s.length is not 0, then we will check if t.length is 0. That is, some characters are still not found, but we have reached the end of t. So we return false in this case. And after these cases, just check if the first character of the substring of the substrings match, then our job is reduced, one character less in each of these. If they are different, then just look for this S in the substring from 1 to last of t. So that's very simple. So let's see the time complexity. Here we are doing one scan of S and t. So time complexity would be order of n, whichever is larger, or n plus m. And we are not storing anything in some extra space. So space is order 1. Time is order n, linear, n plus m, and space is order 1. So let's write this simple code in C++, Java and Python. So if this is subsequence, a smaller string is empty, that means all characters are found, then we return true. If that is not the case, we will go to next line. If it's 0, this function will not execute further, but if it goes beyond this, that means S is not empty. Then if T is empty, t.length is 0, then return false. And if s0 is equal to t0, return if first characters are not same, then return s will remain same, and this will be the substring of t from 1 to last. And let's see, it works. So let's submit, and the solution is accepted. And we are here around 63%. So you can try some iterative approach, maybe that should give some better timing. Here maybe recursion is causing some slowness, but still it's not that bad. Time complexity is O of n only. And now let's write the same thing in Java. And this solution is also accepted. And here also we are around 50% mark. So this P could be mainly due to some iterative approaches where you can have two pointers. One will be pointing to the current character we are trying to search in the character that we are trying to find. So that will be in S. So if we are trying to find A, that will be pointing to A, and the second will be the current position in T. So if we found here, then we will advance it and it both, then we will look for B. So this pointer will remain stationary here, the first one, and the second will keep advancing, and here it will find B. Then we will advance this by 1, this by 1, and then we will find C in the end, and then we will check that if S has reached the end or not, then we will return true. So you can try this. This logic would be very similar to this, and that should give a better result. Now let's write it in Python 3. And the Python solution is also accepted. Now let's try that two-pointer approach, if we can do it better. If S is empty, return true. And then idx1 equal to 0. Or let's call it S for index in S, and idxt so we will look for all the characters in T. If Ti is equal to this SIDX is pointing to the character which we are searching. So SIDX, then what we will do, we have to advance this pointer in S. So SIDX plus plus, and this I we will anyway advance. And if SIDX is equal to S dot length, so the last index will be S dot length minus 1. So if it's S dot length, that means we have searched all the characters of S. So we return true, so that we don't continue our search even if we have reached the end of S, and we don't get an out of bound exception here, since this should be less than S of length. So we return true. But if that is not the case and we have reached the end of this loop, then we will see we have reached the end of this bigger string, but have we reached the end of this smaller string or not? So return sidx should be equal to s dot length. If it's less than that, that means we did not get a chance to search all the characters of s and we reach the end. So let's see if this works. Okay. This works. Let's submit if it passes all the test cases or not. And this solution is accepted. And you see that our solution is right here. It was earlier here around 63%. Now it's 85.4%. And it's just a matter of time that you try a few times. It can reach this peak also, that is 99%. So you see that we get a much faster running time in the case of this iterative solution. I think we did not use this one, so we can get rid of this and this would work. So we needed just one pointer. Other pointer is this I itself. Let's submit again. And we are still here. These are the top two bars. But I believe that we can jump to this without too much of effort. So now let's try our code, the same logic in Java and Python also, and see if there is any improvement there also or not. I think this loop, this check may also not be required since we are already taking care of this. And everything else is fine. t.char at I. And this solution is also accepted. And now we have reached our almost there. We are almost there. We are better than 93% of the submissions. So this iterative approach is working better in not just C++ but Java as well. Finally, let's, for the sake of completeness, do this in Python 3 as well. And this is also accepted. And here also we are right in the towards the top of the region, that is around 93%. So I hope you understood both of the approaches, recursive as well as iterative. The logic is same in both the cases. We make one scan of both of these, and if we reach T at the end, but we have not reached the end of S, that means we have not found all the characters of S in the order they are in S. So we return false in that case. Now let me try one more thing. This check was redundant. Let's see if it improves anything. And here we are at the top 100%. So we have reached our destination finally with improving our solution slowly and slowly. So that check was not required, and removing that helped us jump from here to here. So I hope you liked both the approaches. Feel free to share your valuable feedbacks. Thank you.